Yes, sir.
So, any question from the last lecture? The class quick question.
No, sir.
Okay, so we were at the methonator, and here basically we converted the remaining CO and CO2 into methane. Because why methane? Because methane is has no any adverse effect on the ammonia synthesis catalyst. So the stream which is coming out from the methonator and going directly into the ammonia converter, it will have methane, nitrogen, hydrogen, and some very low amounts of other impurities which were present in air in the form of maybe argon. So firstly, just assume that this stream which contains nitrogen, hydrogen, and methane, which is coming out from methonator, it goes into the compressor, and after getting the required temperature and pressure, specifically pressure from compressor, it goes directly into the ammonia converter. Instead of going towards this path, for the first time, when this plant will start operation, so just visualize that after this compressor, after getting the required pressure, this stream directly goes into the ammonia converter.
Excuse me, sir.
Yes,
सर वो काइंडली रिकॉर्डिंग स्टार्ट कर
जी
दें,
जी
शो नहीं हो रहा.
निकालो. So just assume that after getting the pressure from this compressor, the this stream directly goes into the ammonia synthesis reactor or ammonia converter. It will not follow this path for the first time. Instead, the stream after compressor will go into this converter. तो आपने ये assume करना है कि इस कंप्रेसर के बाद जो स्ट्रीम है वो डायरेक्टली कन्वर्टर पे जाएगी, इस पाथ को फॉलो नहीं करेगी. So in the compressor, the pressure of the stream will be increased to 151 kilogram per centimeter square from 27 kilogram per centimeter square, and this is the reaction which will take place in the ammonia converter. The pressure is for it is 100 to 250 bar, temperature is 350 to 550 degrees C. The reaction is reversible by nature, and uh, since the reaction is reversible and the equilibrium conditions in this reversible reaction is of such nature that we decide to have a 20 to 30% conversion of the reactants in the reactor into the ammonia per pass. This is actually the this range basically is defined based on some practical or experimental data. That if we try to go beyond this range, if we look for higher values, then the conversion or the control of the uh, reactor, ammonia synthesis reactor, it was not good, and it was the process becomes uneconomical, economically feasible नहीं रहता. So based on that experimental data, per pass conversion is set in between this range, and this reaction requires an iron catalyst. So the same chemistry and the reaction is exothermic by nature as well. and we have to remove this exothermic heat. Otherwise, the reversibility of the reaction will start and ammonia will start to decompose into its reactants. So this is the whole chemistry which will be taking place in this ammonia reactor. So after uh, uh, the desired time which we want to give to the reactants for the reaction, we will draw out the product stream, and this stream will have ammonia, the main product, unreacted reactants, nitrogen, hydrogen, and methane, which was formed here. So firstly, we cool this stream in this heat exchanger. So whenever we cool down a gaseous stream, we reduces the temperature of a gaseous stream or a gas. Its pressure also drops. So after cooling it, we send this product stream onto two paths. One path is this one, which we termed as purge. The other path is this one, which goes through a compressor, and after getting the required pressure, this stream is mixed with the fresh stream of the reactants coming from methanator after this compressor. Once again,
सर प्लीज ये प्रोडक्ट स्ट्रीम दोबारा एक्सप्लेन कर दें.
जी मैं एक्सप्लेन कर रहा हूँ. सो जो भी हमने पर पास टाइम सेट किया होगा जिसमें we want to have this conversion, उस टाइम के बाद we will draw out the product stream from the ammonia converter. This stream will have ammonia, unreacted reactants, nitrogen, hydrogen, and methane, which was formed here. These are the major components here. So firstly, we pass this stream through a heat exchanger because it's an exothermic reaction. If we do not remove this heat, the decomposition of ammonia will start. So that is why we cool down this product stream here. After reducing its temperature, its pressure will also decrease. So after this heat exchanger, we send it towards two paths. One path is this purge path, and the other path is this path in which the stream is passed through a compressor. The same stream is passed through a compressor, and after getting the required pressure, इसको मिक्स कर देते हैं फ्रेश स्ट्रीम से जो मेथनेटर से आती है और कंप्रेसर से रिक्वायर्ड प्रेशर लेती है. उस पॉइंट पे वी मिक्स दीज स्ट्रीम्स. ठीक है. So what is this purge? As I already told you that this stream which is coming out from the ammonia converter, it has unreacted nitrogen and hydrogen, and we have to reuse these unreacted reactants. इसमें जो कि अनरिएक्टेड नाइट्रोजन हाइड्रोजन है और हमने इनको रीयूज करना है, इनको वेस्ट नहीं करना क्योंकि इन पे इनकी कॉस्ट है. अगर वेस्ट करते हैं तो हम लॉस में जाते हैं. तो हमें इन्हें रीयूज करना है, इसके लिए फिर हमें इन्हें रिसाइकल करना पड़ेगा. सो दैट रिसाइकलिंग will be performed using this compression path. ठीक है. जो अनरिएक्टेड रिएक्टेंट्स की रिसाइकलिंग है उनको दोबारा से रिएक्टर में भेजना है, वो इस पाथ से होगी जो कंप्रेसर की तरफ जाता है और फिर आगे फ्रेश फीड से मिक्स होता है. And secondly, it has ammonia, which is our main product. So we have to separate this ammonia from unreacted reactant. तो हमें इस अमोनिया को भी इस unreacted reactant से separate करना. तो इस पाथ में दो काम होंगे, nitrogen and hydrogen recycling and ammonia separation, which is our main product. What is this purge? So as you can see that we are working on an operational cycle. कि feed आएगी, it will pass through a separation process, then the stream will go into the reactor, Some amount of the reactants will react, remaining amount will be unreacted. We will draw it, we will recycle it, then we will perform separation, we will send them back again to the reactor. तो ये एक cyclic process चल रहा है. Since the conversion is not 100%, ठीक है, due to the equilibrium condition, the conversion is not 100%. So the accumulation, I hope you guys knows what accumulation is. The accumulation of certain compounds will start to begin. Accumulation का पता है ना? जी class.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
So in order to uh, relax the process from this accumulated amount, and secondly to put the check onto the pressure of the streams or of the reactor, एक तो सिस्टम को इस accumulated amount से थोड़ा रिलैक्स करना है, दूसरा जो ज़्यादा इम्पोर्टेंट है, इस accumulation की वजह से प्रेशर बिल्टअप होगा, तो अपने इस साइकिल के प्रेशर को चेक में रखने के लिए, कंट्रोल में रखने के लिए, we send some amount of this product stream, कुछ अमाउंट इस प्रोडक्ट स्ट्रीम की we send it directly into the environment, उसको डायरेक्टली इन्वायरमेंट में भेज देते हैं. So वो stream which is sent directly into the environment so that we can have a check on the pressure of the system and we can have a check onto the accumulated amount of the compounds. उस stream को we call it as purge stream. So it's the purge stream does not contain very huge amount of the components. It just contains a very little amount of the components. बहुत थोड़ी सी amount इसमें होती है. बस हम इसको send करते हैं into the environment so that we can have all the operating conditions under control. Like अगर आपको प्रेशर कुकर का कभी आपने ऑपरेशन देखा हो ना, so उसके ऑपरेशन में एक टाइम आता है जब थोड़ी थोड़ी करके स्टीम उसकी नोजल से बाहर आती है, कंटिन्यूसली नहीं आती, थोड़ी थोड़ी देर के बाद थोड़ी थोड़ी सी अमाउंट ऑफ स्टीम इट कम्स आउट फ्रॉम द प्रेशर कुकर आफ्टर अ वेरी लिटिल टाइम ऑन ए रिपीटेड बेस. रेपिटेशन पे थोड़ी थोड़ी सी अमाउंट प्रेशर कुकर से स्टीम की बाहर आती है. सो दैट इज पर्जिंग. व्हाई दे आर पर्जिंग? क्योंकि वो सिस्टम के प्रेशर को चेक में रखने के लिए. ठीक है. सो आई होप ये पर्ज स्ट्रीम का ऑपरेशन समझ आ गया सबको. जी क्लास, पर्ज स्ट्रीम का ऑपरेशन समझ आ गया?
Yes,
Yes,
sir.
sir.
जी सर.
ओके. अब दूसरा पार्ट विच इज दी.
सर ये रिपीट कर सकते हैं प्लीज?
ऐसा चूंकि मैंने पहले बयान किया कि रिसाइकलिंग है इसमें अनरिएक्टेड रिएक्टेंट्स की और हमने इसको रीयूज करना है. 100% कन्वर्जन नहीं है कि सारे रिएक्टेंट, सारे जितने भी रिएक्टेंट्स ऐड किए वो सारा प्रोडक्ट में कन्वर्ट हो गया तो हमने जस्ट प्रोडक्ट को विड्रॉ कर लेना है. ऐसा सिस्टम नहीं है. इसमें रिएक्टेंट्स भी हैं और इसमें प्रोडक्ट्स भी हैं. प्रोडक्ट को सेपरेट करना है, रिएक्टेंट्स को रिसाइकल करना है ताकि रीयूज कर सके. तो एक्यूमुलेशन स्टार्ट हो जाती है और उस एक्यूमुलेशन की वजह से चूंकि गैसियस सिस्टम है, प्रेशर का लोड बढ़ता है. सो इस चीज़ों को चेक में रखने के लिए कि हमारे रिएक्टर का जो ऑपरेशन है वो नॉर्मल रहे, अंडर कंट्रोल रहे, अंडर चेक रहे, हम कुछ अमाउंट इस प्रोडक्ट स्ट्रीम की डायरेक्टली इन्वायरमेंट में भेज देते हैं. उससे प्रेशर की तरफ से सिस्टम को रिलीफ मिलता है, थोड़ा अक्यूमुलेशन की तरफ से सिस्टम को रिलीफ मिलता है और इस तरह करने से जो ऑपरेशन कंट्रोल है वो बहुत अच्छा रहता है हमारा रिएक्टर पे. ये अब क्लियर है?
यस.
Okay ji. So the second path of this product stream, firstly we pass it through a compressor. Why? Because we will mix this stream with the fresh steam which is coming from the methanator and pass through this compressor. Okay? As both streams are gaseous streams. So whenever we are mixing normally two gaseous streams, their pressure should be same. ठीक है, ये रूल ऑफ थंब है. जब भी आप गैसियस स्ट्रीम्स को मिक्स कर रहे हैं, उनका प्रेशर सेम होना चाहिए. The stream which will have high pressure, it will not allow the pressure having a low, it will not allow the stream having a low pressure to enter in this mixing point. For example, this stream has high pressure, this stream has low pressure. So high pressure stream will not allow this low pressure stream to come into this mixing point because it has high energy content. It can repel this low energy content stream very easily. ऐसे ही जैसे एक वजनी आदमी, एक मोटा आदमी, बल्कि आदमी, वो एक थिन पतले से आदमी को बहुत इजीली हटा देता है. ठीक है. So the same concept is here. The high pressure stream will not allow any low pressure stream to enter into this mixing point. So especially in case of gases, if we are mixing two streams under normal operation, the pressure of both streams should be same. Okay. So this compressor is giving pressure of 151 kilogram per centimeter square or 100 to 250 bar. So the pressure of this stream is 151 kilogram per centimeter square. Then this stream should have the same pressure as well, 151 kilogram per centimeter square. If both have same pressure, then they can mix. And for this purpose, we have to pass this stream through a compressor so that it can also have a pressure of 151 kilogram per centimeter square. So why this input stream has low pressure? Because we cool it down in this heat exchanger. And this cooling process, the reduction in temperature will also cause a reduction in pressure. So the stream will have low pressure. That is why we will compress it to the desired pressure, and then we will mix it with this fresh stream coming from the methonator and compressor. So this mixing thing is clear.
जी सर.
Yes.
Okay. So now this stream, which we get after mixing these two streams, right? It has unreacted hydrogen, or it has unreacted reactants and our main product, which is ammonia. Now we have to separate ammonia from the unreacted reactants, and the unreacted reactants will go back into the reactor while the ammonia will be separated out as a product.
सर स्ट्रीम के अंदर मीथेन भी होगी ना?
जी जी जी, मीथेन भी होगी. So in order to separate a gaseous compound from a gaseous mixture, क्योंकि ये सारी गैसेस ही है ना, तो इसमें से एक गैस को हमें बाकी गैसेस से सेपरेट करना है. ठीक है. So we choose a separation of liquefaction, that the components which we want to separate